In the last video, we explored what black holes are and how they form. But once we understand that these objects exist, a much more unsettling question naturally follows. What would happen if you fell into a black hole? Although no human has ever been anywhere near a black hole, scientists can use the laws of physics to predict what would happen. By combining Einstein's theory of general relativity with what we know about gravity and motion, we can describe the experience step by step, from far away all the way to the center. Imagine that you are floating far away from a black hole in space. At this distance, the black hole's gravity would not feel especially different from that of a normal star with the same mass. Gravity weakens with distance, so unless you were very close, you would not be suddenly pulled in. In fact, if our sun were magically replaced by a black hole of the same mass, the planets would continue orbiting almost exactly as they do now. As you move closer, however, the effects of gravity begin to change. The gravitational pull becomes stronger and, importantly, uneven. The part of your body closer to the black hole would experience a stronger pull than the part farther away. This difference in gravitational force is known as a tidal force, and it becomes more extreme the closer you get. As these tidal forces increase, your body would begin to stretch. Your feet would be pulled more strongly than your head, causing you to elongate. At the same time, gravity would compress you from the sides. This dramatic stretching process is called spaghettification because you would be stretched long and thin like a strand of spaghetti. What happens next depends on the size of the black hole. For smaller black holes, these tidal forces become deadly long before you reach the event horizon. However, for supermassive black holes, the tidal forces near the event horizon are much weaker, meaning you could cross it without immediately noticing anything unusual. The event horizon is the boundary surrounding a black hole where escape becomes impossible. From your own perspective, crossing the event horizon would not feel sudden or dramatic. You would not see a wall or feel a jolt. You would simply continue falling inward, unaware that you had passed the point of no return. However, an observer watching from far away would see something very different. As you approach the event horizon, your motion would appear to slow down. Your image would seem to freeze in place and gradually fade away. This happens because time itself slows down near a black hole due to its intense gravity, an effect known as gravitational time dilation. Once inside the event horizon, the escape is impossible. All possible paths through space and time lead towards the center of a black hole. As you fall deeper, the tidal forces become stronger and stronger, eventually tearing matter apart completely. At the very center lies the singularity, a point of infinite density where our current laws of physics break down. What actually happens there is still unknown, making black holes one of the greatest unsolved mysteries in science. So, falling into a black hole would not be sudden or dramatic at first, but it would quickly become deadly as gravity stretches space, time, and matter itself. But there's an important problem. If black holes are invisible and nothing escapes from them, then how do we know that any of this is even real? How do scientists know black holes actually exist in the first place? That question leads us to the final video in this series. Thank you for watching and see you in the next video.